A machine so colossal it broke the company that built it. A land train stretching nearly 600 feet, canceled before it could ever deliver. What if the costliest engineering dreams can destroy their own creators? These are not stories of failed inventions. They are tales of ambition colliding with politics, shifting markets, and impossible promises. Subscribe for more hidden chapters in engineering history as we uncover the real cost of building too big and reveal how the world's largest machines became financial disasters. So how does brilliance become bankruptcy? Let us start with the first casualty. In the quiet town of Portogruaro in northern Italy, Umberto Acco set out to build a machine that would dwarf anything Caterpillar had ever produced. The result was a super bulldozer weighing 183 metric tons, fitted with twin Caterpillar diesel engines that together delivered more than 1,300 horsepower. Its blades stretched 7 meters wide, and the entire machine measured over 12 meters long, every detail oversized, every component custom ordered or modified for one purpose: to shape the Libyan desert under a single government contract. As the Dozer neared completion in the early 1980s, Acco's factory floor buzzed with urgency. The Libyan deal promised a windfall, but it also meant all bets were placed on a single client. In 1986, international sanctions hit Libya overnight, freezing exports and trapping the Dozer in Italy. The machine was too large for standard shipping, and the cost of moving it made resale impossible. Attempts to repurpose its sister grader for local work failed, and that machine was eventually scrapped. The Super Dozer remained unsellable and idle, draining the company's finances as it sat exposed to the elements. When Umberto Acco died, the company faded with him, its yard littered with stranded giants. The Super Dozer survived only as a monument to ambition and to the risk of building for a world that can change with a single headline. Stretching nearly 600 feet from cab to tail, the LeTourneau TC497 Overland Train Mark II was the longest off-road vehicle ever built. 4 gas turbines sat atop its articulated modules, generating electricity for 54-wheel motors, 336 wheels in all, each driven independently. Designed to cross the Arctic with 150 tons of cargo, the train included living quarters for its test crew and could travel for days without resupply. Project Otter, the Army test program at Yuma Proving Ground, put the land train through its paces in 1962. Engineers tracked performance on sand and gravel, steering the giant machine with early computer controls. But while the TC-497 rolled across the desert, military logistics were changing. New Arctic highways and the arrival of heavy-lift aircraft like the C-130 Hercules made the land train's promise obsolete almost overnight. Procurement for further units was canceled in the mid-1960s. LeTourneau's investment, years of design, custom fabrication, and field testing yielded a machine that never saw real service. The cost of innovation sat on the balance sheet, and the crew who once rode its length watched as the overland train was broken up for scrap, a casualty of progress outpacing invention. In October 1939, a convoy rolled away from Chicago carrying something that looked more like science fiction than a research vehicle. The Antarctic snow cruiser stretched 55 feet, its smooth, oversized tires promising to glide over endless ice. Engineers on Admiral Byrd's team watched with pride as the diesel-electric machine left the city, its roof loaded with a small plane for aerial surveys. Spirits ran high. The cruiser was the centerpiece of America's second Antarctic expedition, a bold answer to the continent's frozen secrets. But once the ship reached the Ross Ice Shelf, the machine met its true test. The tires, designed for soft snow, spun helplessly on glare ice. Each attempt to gain traction only dug the wheels deeper or sent the vehicle skidding sideways. Mechanics tried sandbags for weight and even wrapped the tires in chains, but the cruiser barely moved. Days of trial and error turned into weeks. The Antarctic wind howled outside as the crew realized the machine would never roam the ice as planned. With World War II looming, government funding vanished. The snow cruiser was reclassified as a stationary shelter, its engine silent, its promise unfulfilled. When the expedition departed, the crew left it behind, buried in snowdrifts. Diaries mention the bitter cold and the long hours spent inside, waiting for rescue flights. In the end, the Antarctic terrain had claimed another victim, not through force, but by exposing every weakness in a machine built for a world it could not conquer. Big Muskie stood alone in the rolling hills of Ohio, a giant among machines. Weighing 13,500 tons, it was the largest walking dragline ever built, its 220 cubic yard bucket able to scoop up enough earth to fill a swimming pool in a single pass. Built in the late 1960s, Big Muskie drew power from its own dedicated substations, consuming as much electricity as a small town every hour it ran. Night crews of welders and electricians kept the behemoth moving, their shifts lit by the blue sparks of arc welders and the hum of high-voltage lines. But the world outside the pit was changing. Coal prices peaked in the early 1980s, then began a steady slide. By 1991, the price of Ohio coal had dropped more than 30% from its highs, squeezed by competition from natural gas and stricter environmental standards. The Surface Mining Control and Reclamation Act of 1977 forced costly new reclamation work, shrinking the massive pits Big Muskie was built to serve. Later, the Clean Air Act of 1990 penalized high-sulfur coal, hitting Ohio mines especially hard. Operating costs soared while demand evaporated. For the crews on night shift, the writing was on the wall long before the final shutdown. In 1999, after 30 years of service, Big Muskie was cut apart for scrap. The machine that once moved mountains finished as a memory. Its scale and power were no match for the shifting tides of regulation and economics. Every launch at Kennedy Space Center begins with a ritual of slow, deliberate movement. Beneath the rockets, the crawler transporters, each weighing over 2,700 tons, inch along the gravel crawlerway, their steel track shoes pressing deep into the bed of Tennessee River rock. 16 hydraulic jacks, each the size of a compact car, constantly adjust the platform to keep the load level, compensating for even the slightest slope or dip. Technicians walk alongside, eyes on pressure gauges and radio handsets, listening for the first hint of trouble from the labyrinth of hydraulics and electric motors. Florida's salt air is a relentless enemy. Corrosion eats through steel beams and track links, forcing maintenance crews into a cycle of sandblasting, welding, and repainting that never truly ends. In the early 2000s, NASA spent $89 million on a corrosion control program just to keep the crawlers operational. The upgrades did not stop there. By the time the Space Launch System arrived, the crawlers had received $160 million in new hydraulic jacks, wider track shoes, and reinforced platforms, each round of improvements more expensive than the last. Federal audits track the spending, line by line. Billions spent over decades, with annual maintenance alone sometimes topping $50 million. But unlike the commercial giants left to rust or scrapped for parts, the crawlers are too essential to retire. For the technicians who coax these machines through another humid Florida summer, the work is both routine and monumental, a daily battle against time, weather, and the creeping cost of keeping history's biggest support vehicles moving. In a cavernous hangar on the California coast, teams of craftsmen shaped thin sheets of birch and spruce into the largest flying boat ever built. The H-4 Hercules, better known as the Spruce Goose, stretched 320 feet from wingtip to wingtip, wider than a football field is long. 8 radial engines lined its wings, each one hand-fitted by mechanics under the watchful eye of Howard Hughes. The war had demanded a cargo plane that could cross oceans while avoiding enemy submarines. But wartime aluminum shortages forced designers to turn to wood, layering strips of veneer into a skin as strong as metal. Hughes poured his fortune into the project, pushing for perfection at every step. Delays mounted. Costs soared past $23 million, and as the war ended, the military canceled its order. Congressional hearings called Hughes to answer for the spending. In November 1947, with reporters and skeptics gathered on the Long Beach harbor, Hughes himself took the controls. The Hercules lifted off for a single mile, just above the water, then settled back, its only flight. After that brief moment, the H-4 never flew again. Hughes refused to let it go, paying for a private crew to maintain the plane in a climate-controlled hangar for nearly 3 decades. The cost of preservation ran into the millions, draining resources year after year. When Hughes died in 1976, the Hercules was quietly transferred to a museum, its wings still immaculate, its engines silent. For Hughes, the H-4 was more than a machine. It was proof of vision and a burden that outlasted its creator. Today, even as technology grows more ambitious, the risk of building for yesterday's needs remains. In an era of trillion-dollar megaprojects, the line between vision and overreach is razor thin. Every giant machine still asks the same question: who truly pays the price for dreams scaled too large? Thanks for watching.